All right, so let's do some scientific notation. Scientific notation. All right, so let's say we have a number 15,000. That's kind of how that's our number system, right? So that's called standard. I think in Europe it's called decimal form. Okay. And if I wanted to turn that number 15,000 into scientific notation, the rules are I go all the way to the left and put the very first digit down that begins with a number. So, and we follow it with a decimal. So that means the first place all the way to the left is a 1 through 9. That's all it's allowed to be in scientific notation. Okay, is a 1 through 9. We'll do some more examples in a minute. And then I put a decimal, put any other numbers that are in that number, and then cross off any kind of extra zeros that they have. So, in other words, this number is going to turn into 1.5, lop off the rest of those zeros, and then put a 10 next to it, times 10. This is what scientific notation all is about here. And we want to take the decimal from 15,000 and put it over here. We want to see how far that went. So 15,000 has a decimal point right here. You just don't see it. Okay. And we just want to count the spaces. 1, 2, 3, 4. We moved it 4 times. 1, 2, 3, 4 to get it to where it is now. So that's how we get a 4 over there. Okay, so if we saw this number somewhere in scientific notation, 1.5 times 10 to the 4th, we write the 1.5 down and then we move it 1, 2, 3, 4. It goes there. That means there are 3 more zeros that go in there. So 15,000 in scientific notation is this number right here. Okay, in standard notation, it's the 15,000. So let's try another one. Let's say we have 885. By the way, this is, if you're in our book, it's 5.3, and this is on page 191. Okay, so let's say we have 885. That is in standard form. I need to convert it to scientific notation. So that means we put the 8 that's all the way to the left and a dot, and then all the numbers left that are there, and then times a 10, and then how far did we move that decimal? The decimal's here, and we went 1, 2, so we moved it 2. All right, so that means we would move it back if we needed to put it back in standard notation. So those are for big numbers. Notice that our exponent on the 10 is positive for large numbers. Okay, so you know what's coming next. What if I had so I'm going to put a 0 here, 0, 0, 0, 1, 2. Okay, let's say that number is in standard form. It's just a really little number, right? We want to convert it to scientific notation. So we're going to put 1, that's the number, that's the only whole number I have that's to the left. And then we put a decimal, any other numbers, and then we count how far we had to move it. 1, 2, 3, 4 to get it there. So that means this is times 10 to the negative 4 because we moved it back the other way because it was a really small number. So exponents that are negative are small numbers. Okay. So let's do another example. Let's say they gave me 2.56 times 10 to the second and said, give me this in standard form. 2.56 to the second, that's a positive exponent, so that's a bigger number. So I move it 2 places. That means it goes there. So my final answer is 256. Okay, so what if it said 6 times 10 to the negative 5 Well, negative means it's a small number, and I'm going back the other way. So 6 has a decimal right there, and it's 1, 2, 3, 4, 5. That means I'm putting zeros in all the little hoopsy things here. So my final answer for that one had 4 zeros and a 6. So that would be the standard form of that one. All right. And then I think the tough ones are the multiplication ones and the division ones. So they're going to give you something like 2 times 10 to the 4th times 6 times 10 to the 2nd. So how you're supposed to handle these is to regroup them. This is multiplied, and then these are multiplied towards each other. So take a moment. I like to write down this step, and it's this times this, and 10 to the 4th, plus 2? Because this is why they're in this section. We practiced exponents. Sorry, that's a little messy looking. Let me put this over here. 10 to the 4th plus 2. All right, so that's going to equal what? 12 times 10 to the 6th. But it's not proper scientific notation because I have the decimal right now is here. I need to move it back over to here. So this is how I do this, so I remember not to mess this up. A 12 is what in scientific notation? A 12 is 1.2 times 10 to the positive 1. Okay? So the positive 1 and the positive 6 make it my final answer for this problem would be 1.2. Let me fix that. 1.2 times 10 to the 7th. Okay, so just in case I'm feeling a little insecure about that, 1.2 times 10 to the 7th, that would be 1, 2, 3, 4, 5, 6, 7. Then let's put some commas in here so I can tell. 1, 2, 3, 4, 5, 6 zeros. 2, 3, 4, 5, 6 zeros. That means the decimal's over here. And if you put in some commas, that means 12 million. So let me check that number up here. We had 2 times 10 to the 4th. Well, that equals 2. 1, 2, 3, 4. And 6 to the 2nd, which would be 6, 1, 2, 600, 20,000 times 6, times 600, put that in your calculator, and you should get 12 million. Okay, so the idea is to multiply the constant times the constant, then add your exponents to do that. And then the other problem you're going to get is a division. So let's do 5.33 times 10 to the negative 6 divided by 9.62 times 10 to the negative 2. Well, that looks really bad, but remember what we're doing is we're going to take 5.33 and divide it by, in our calculator, 9.62. So take a minute to do that. You're going to get 5.12746, apparently. Okay. Let me check that. That doesn't sound right. I should get a much smaller number. 5.33 divided by 9.62. Yeah, that's wrong. Sorry. And pushed the wrong. I think I multiplied or something. I don't know. That's going to be. It's right over here. 0.5. That makes more sense. Sorry. 5, 4, 4. Lots of decimals, and it keeps going. So I'm just going to stop right there. All right. That number divided by that number is that number. All right. And then this right here is what? That is 10 to the negative 6 minus a minus 2. That's why this is in this chapter, so because we just did negative exponents. So that's like 10 to the negative plus 2, which is 10 to the negative 4. So right now my answer looks like 554054 times 10 to the negative 4. Well, this isn't proper scientific notation. I need to move this over one place to here. So I know my final answer is going to start like that. And if it goes on long, the homework should tell you how many decimals that it wants. And let's see, we moved it. Let me take a step back. If I'm moving it one place, I'm making it larger, so this one is a negative 1. So this is going to be a negative 1 plus a negative 4, which is going to be 10 to the negative 5. So that's my final answer for that one, because we did a negative 4 plus a negative 1. So this was a little number. We were making it bigger, so it goes the other way. Yes. Instead of making it smaller. So watch which way. I think that's the hardest part. When you come down to this number, try to think of it independently. If you had to put this number into scientific notation, you'd be moving it one this way. Okay, it's a really little number that we're making bigger. So that is a negative, okay, when you fix it. And when you're adding it back to this part, it's going to be a negative 5.